Another way of describing your data is in terms of the symmetry, okay? And so it kind of comes down to your graph is either going to have symmetry to it or it's not, okay? And so if it has symmetry, you guys can have kind of learned from other grades what symmetry means. If something has symmetry, you're looking at it and you can kind of draw a line down the middle of it to where one half is kind of like the mirror image of the other one. So if you fold it over that line, then it kind of matches up on both sides. And so if the graph has a line of symmetry to where you fold it over and it looks the same on both sides, or it matches up on both sides, then it is what's called symmetric. And so some examples of that would be like if you graph your dot plot or whatever, and it kind of maybe, let's see if I can draw this, maybe it looks like that. So notice it's not perfect, but a lot of times in statistics when you graph things, they're not going to be perfect. But like if you look at this line that I just drew, you can see that if I fold that over that line, let me draw that line a little bit darker because it's kind of hard to see. If I fold this over that line, it kind of matches up on both sides. So that graph, you could say, has symmetry to it. So you could say that it's symmetric. Same thing if you graphed something and maybe it formed that kind of graph. I don't know what that would look like, but notice that, that has a line of symmetry to it, where if I fold it over that line, it matches up on both sides. So you could describe that as symmetric. Some other types of graphs you could see. You could have a graph that has multiple peaks to it. So if you had something like that, kind of looks like a ghost. But if you graph your dots and it has like a peak right here, and then your other dots kind of peak right there, and then some more right there, notice you have a line of symmetry here. So if I fold it over that line right there, it'll match up on both sides. So that graph is also symmetric. Another example that isn't as seen as often is what if you graph it and it kind of looks like that. Well, that does have a line of symmetry. It's kind of weird, but it has a line of symmetry to it, because if I fold it over that line right there, it will match up on both sides. And so these would all be symmetric. There's other ways of describing it. If you think back to what we talked about with modes, both of these would be what's called unimodal because they have one peak. This one would be trimodal because it has 3 peaks, and then that one would be bimodal. So there's other ways of describing it, okay? So that's what symmetric means. So if it looks kind of symmetric, then you could say that it's symmetric. Something else that you could look for if you're not sure, like, because some of these, it could be questionable. It might not be perfectly symmetrical, but it looks like it could be. Something else you could check for is with graphs that are symmetric, you're going to find that if you find the mean, and remember mean is where you add up all your data and then divide by however many they are, and you find the median, if they are about the same or they're really, really close to the same number, then that's a good indicator that your graph would be fairly symmetric. And so if you're not sure, you can find the mean and the median and compare them. And if they're about the same number, they don't have to be exact, but if they're about the same number, then that's a good indicator that it's symmetric. Okay? So then what happens if your graph is not symmetric? If the graph is not symmetric, it's either going to be what's called left skewed or right skewed. Okay? It's going to depend where what we call the tail of your graph is. Okay? And so we're going to talk about that. Okay? So what does it mean to be left skewed? Well, remember, these graphs are not going to be symmetric. So these are the ones where it doesn't have symmetry to it. So if you graph your data, and I'm going to actually put dots this time. Let's say that the majority of your data, so like your dots, the majority of your dots ends up being maybe over here. So I'm going to draw a dot plot. It's not going to be perfect. Let's say that you draw your dot plot, and it kind of, as you go this direction, you kind of have less and less numbers that are in that direction. So if it looks something like that, Notice the general shape, it kind of fizzles out on this side, and then the majority of your numbers are on that side. If it kind of forms that shape, that would actually be left skewed. And so I'm going to talk about what makes it left skewed. I mentioned that you look at where the tail of your data is. So like, look at this, the hump of your data, the mode is over here. So the majority of your dots are over here. But notice as we go to the left, it kind of has less and less data. So that would be the part, it kind of looks like a tail. So the part where it kind of trickles off and it looks like a tail, that is the type of skewness it has. So notice the tail of your data is on the left. And so this would be left skewed. So if the, and this would actually be kind of where your outliers would be, because these don't fit the normal or the norm of your data. And so if your outliers, or if your graph kind of goes down on the left, or the tail of your graph is on the left, then you would say that it is left skewed. So the outliers for these will be on the low end, okay, of your graph. And that's how you classify it. So if it looks like this and the tail is on the left, then you would say that it is left skewed. So tail on the left, okay? The other way that they can classify this, instead of saying left skewed, sometimes you'll see that they will say that it's negatively skewed. And the reason for that is because think about what kind of numbers, if we kept going this way, think about what kind of numbers are in this direction. Those, if we would eventually get to the negative numbers. So sometimes you might hear that they will call this negatively skewed instead of left skewed, but it means the same thing, okay? So if the tail is on the left, then it's negatively skewed or left skewed, okay? So something about this, kind of like what I talked about with symmetry, for some of these problems it's going to be kind of hard to tell because, you know, some of them you might be in between, you know, maybe saying it's left skewed or symmetric and you're not sure. Find the mean and median, and if they're about the same thing, then you would say that it's more symmetric. But how do you know if it's more left skewed? Well, think about what I was talking about over here. I said that your outliers will kind of be on the low end. And think about these numbers are smaller than the ones that would be on this side of your graph. So if you find the mean and the median and you compare them, for this graph, because these outliers, like you're going to factor in when you find the mean, think about what that does to the mean. If you're factoring in some really low numbers, like for instance, if you're looking at grades and you have a couple zeros, think about what that does to your grade. It brings your average, which is your mean, it brings it down. And so if you have outliers on the low end, that's going to make the mean actually smaller than the median. So your mean could end up being like maybe a little bit lower. So this could be where your mean is, and then your median is literally that number in the middle. So your median would be kind of higher up. So if you find the mean and the median, and the mean is smaller or less than the median, then that's a good indicator that it's actually left skewed. Okay, so left skewed, if you're not sure, find the mean and the median, and if the mean is smaller than the median, then that means it's left skewed. Okay, so that's something else you could check for if you're not sure which one it is. Okay, so now what if you didn't graph it as a dot plot or a histogram, and you can't see it like that? What if maybe you graphed a box plot? Well, let's talk about what to look for in a box plot to know if it's left skewed. Okay, so think about it. The box plot, you draw your number line and then you graph your box plot. So there's a couple things you can look for. So if I have my box plot and I've graphed it, remember the median is what you graph in the box plot. So if your median is kind of closer to the higher numbers, so if it's more on the right hand side, that actually shows that more of your data is on the right hand side. And so think about what we were talking about over here. the more of the dots are on the right-hand side. So if your median is more towards the right of the box, that actually means the tail will be on the left. And remember, to know if it's left skewed, you're looking at where the tail is. So if more of your data is on the right and your median is closer to the right side of the box, so if the median is more to the right, let's see if I can squeeze that in there. So if the median is more to the right, let me zoom in just a bit, then that would mean that your tail would be on the left. So that would make it left skewed. So that's what you look for in the box plot, is look at where the median is. Another way to look at that is if your tail is, or if the whisker of the box plot is kind of really long on one side compared to the other, that's also kind of a good indicator that as to where the tail of your graph is. So if like the whisker is longer over here, that would also show you that the tail would be kind of on the left, okay? All right, so how do you tell if it's right skewed? Well, it's pretty much the opposite of what we just talked about with left skewed, okay? So if it's right skewed, then that means the tail will be on the right, okay? So the tail is on the right of the graph. And so what does that mean, like in a dot plot or if you graph a histogram? Well, that means that the majority of your dots, the majority of the numbers will actually be on the other side. Okay, so it would look kind of the opposite of what we did. So that means it kind of trickle off as you go to the right. So your general shape would look something like that. Okay, so notice the tail of your graph is on the right. So that would mean that your outliers are more on the upper end of your numbers. So for a right skewed graph, the outliers are on the upper end, or you could say high end of your graph. Okay, so if you're thinking about grades, like I was talking about before, let's say that you struggle in a class and most of your grades are kind of lower, but then you have a few high grades. Well, then that means that it would make your average a little higher, okay? So kind of like what I talked about up here, a way to tell, you know, if you're not really sure if it's right skewed or not, you can find the mean and the median here. And here, and actually I'm going to draw this a little lower. Here, the mean is actually going to be higher than your median because the upper numbers, these outliers up here, will actually pull the average, the overall average, to be a higher number, okay? So here, you can still find the mean and the median, but in these problems, the mean would actually be bigger than the median, okay? So if you were kind of looking at your graph, the mean would be a little higher than where your median would be. So your median would be kind of down here, and then your mean would be higher because those high grades are pulling up your overall average, okay? Something else, kind of like what I talked about up here, I talked about left skewed. It could also be called negatively skewed because think about the numbers that were this direction were negative. So then right skewed because we're looking at the right side, that's where the tail is. Then think about what kind of numbers are this way. Well, these would all be positive the more I go kind of to the right. So another name for right skewed would be positively skewed. So sometimes you might see it called positively skewed instead of just right skewed, okay? So that's how to tell, like in a histogram or maybe like a dot plot, how to tell if it's right skewed. If you're looking at a box plot, it's kind of the opposite of what I just talked about with left skewed. So if you graph your box plot and you're trying to figure out if it's right skewed or left skewed, then up here I talked about if the median was more to the right, that means that more of your data is on the right, so the tail would be on the left. So that's what makes this one left skewed. So if you graph your box plot and the median is more kind of towards the left side of the box, and then, you know, you have maybe a little bit longer of a whisker that way, that would actually mean that this would be right skewed because more of your data is over here, which means that that trickled off part would be kind of towards the right. So if the median is more on the left side, is more to the left, then that would actually mean that it's right skewed, because remember, you're looking at where the smaller amount of data is, okay? So if the median is more to the left, then that means that you have less data, less dots, I guess, on the right side, okay? So that is how you tell if you would classify as left skewed or right skewed.